Y'all still go trick-or-treating? No? How many of you, who's going trick-or-treating? Isn't that Saturday night? What's that? You don't know if what? If they're still doing it. Is trick-or-treating on or off? Anybody know? Yeah, I bet there was something. Yeah, huh, interesting. Be interesting. Anybody in here plan on going trick-or-treating? Yeah. You're going to be rebels just breaking the rules. There you go. All right. All right, today we're going to be talking about geometric mean. And then we're going to be using geometric mean. The geometric mean. Between two numbers. Is the positive square root of their product. So we're going to, got a rule here. The geometric mean of two positive numbers A and B is the number X such that A over X equals X over B. So X squared equals AB. And X equals the square root of A times B. All right, so if you're given or if you're asked to find the geometric mean of the given numbers, and let's say that you're given 8 and 10. So look, since this is the rule, then x is equal to the square root of 8 times 10. So x equals the square root of 80. And now, since the square root of 80 has a perfect square as a factor, perfect square, let's, over here on the right, we're going to make a list of perfect squares. Perfect squares. Those are numbers whose square root is a whole number. So perfect squares. 1 is a perfect square. 4 is a perfect square. And so is 9 and 16 and 25, 36. What's the next one? Can anyone tell me? Good. 49, and then? Good, and then? Good, and then? Good, and then? Good, and then? Very good. All right, those are your first 12 perfect squares. Okay? Because all of these numbers have square roots that are whole numbers. That makes it a perfect square. So when you're dealing with radicals, if the number under the radical has a factor that's a perfect square, then you can simplify this radical. All right, so if x equals the square root of 80, well, that's the same as the square root of 16 times 5. Okay, so let me rewrite it this way. Let me rewrite it as the square root of 16 times the square root of 5. And now the square root of 16 times the square root of 5 can be simplified. All right, so in this case, x is equal to, what's the square root of 16? That's 4 times the square root of 5. So that is the geometric mean of 8 and 10. Now, you want to list those two ways. You want to list this. This is called radical form. Okay? You want to list your answers in radical form and then as a decimal. So as a decimal, we write, or we type in the calculator 4 times 5 square root, and we get 8.9. All right? Radical form and as a decimal. Yes? Square root of 80? 80 square root, 8.9, yeah. But you do have to be able to write it in, yeah. You got to be able to simplify that square root of 80 down to the 4 times the square root of 5. All right, so that was the geometric mean of 8 and 10. Let's do 5 and 45. All right, so x is going to be equal to the square root of 5 times 45. So x equals the square root of 5 times 45 is 225. Now, when you multiply these numbers under the radical and you get a value, all right, if it's over 144 and you don't recognize it, just push the square root button, because the square root of 225 is what? Good, 15. So there is the geometric mean of 225. 225 is also a perfect square. It's on your list. After 144, we go 169, we go 196, we go 225. All right, you really should know your first 15 perfect squares. All right, let's do 12 and 15. So x is going to be equal to the square root of 12 times 15. And 12 times 15 is 180. So x is equal to the square root of 180. So if we're going to simplify this square root of 180, it is not a perfect square. We're going to try to find we're going to find the largest perfect square that will go into 180 evenly. Understand that? Largest perfect square that will go into 180 evenly. So in your calculator, you take 180 and you start dividing it by these perfect squares. Okay? Did anybody do it yet? Nobody's done it yet? You take 180, you divide it by 4, and then by 9, then by 16, then by 25, then by 36, 49. 64 is not going to go, 81 is not going to go, and 100 doesn't go. So you can stop at 49. Yeah, it's 36. How many times does it go? Very good. So look what this simplifies to. This x is equal to the square root of 36 times the square root of 5. So now we can simplify. X equals 6 times the square root of 5. And then as a decimal, 13.4. All right, let's write this down. This is Theorem 8.1. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles are similar. To the original triangle and to each other. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles are similar to the original triangle and to each other. So if we take a right triangle, and call it ABC. And then an altitude. An altitude goes from a vertex to the opposite side and it intersects at 90 degrees. So leaving C, we're going to go to AB and we're going to intersect at 90. That is an altitude. And where C hits AB, we'll label it D. So we have 3 triangles in this picture now. We got triangle ABC. Is similar. All right, look at the order that we went. We went A, B to C. We did hypotenuse. And then in this case, let me put some lengths here so that you can see this. Let's say that this is 8 and 6 and 10. Okay. So that you can see which side's the short leg, which side's the long leg. We went hypotenuse and then from B to C, short leg. Hypotenuse, short leg. So then we're going to say that that triangle is similar to, we need the hypotenuse of this next triangle, which is C to B. And then we're going short leg there, which is D. And that triangle is similar to triangle, this third triangle up here. And now we're going to go C to B, or I'm sorry, C to A, side CA. And then the third side of that triangle is AD, so we go to D. All right, that's the rule. You can use that rule to write similarity statements, and you can use that rule to find missing side lengths. All right, so here's the geometric mean theorem. The altitude drawn to the hypotenuse of right triangle separates the hypotenuse into 2 segments. The length of this altitude is the geometric mean between the lengths of the 2 segments. So look, here's what we got in this picture. Got a right triangle, ABC. We've got an altitude drawn to the hypotenuse. This altitude also represents the height of the triangle, so we're going to call it H. This altitude divided this hypotenuse into 2 pieces. We're going to call one piece X and the other piece Y. And where this altitude hits this hypotenuse, we're going to call that D. So here's what's true about the length of this altitude. The rule says the length of the altitude is the geometric mean between the lengths of the 2 segments. The length of the altitude. is the geometric mean of the two segments it creates. So in this big right triangle, ABC, we took an altitude and we drew it from the vertex to the hypotenuse. Created a segment, segment H. The length of the altitude is the geometric mean of the two segments it creates. It created segment X and segment Y. So that means that H is equal to the square root of X times Y. In all right triangles. Super important theorem. The altitude is the geometric mean of the two segments it creates. The length of this altitude is equal to the square root of this segment times this segment in all right triangles. Now we're going to expand this a little bit, and we're going to label this side right here lowercase b. Side AC, that's lowercase b. And then this is lowercase a right here. So here's what else is true about this altitude and what's going on in this diagram. The altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. That's your segments X and Y. The length of the leg of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So we're going to call all of this that's a lowercase c. All right, so watch. We're going to start by saying, do you see this whole side right here? Here's what's true about it. That C over B is equal to B over X. That means this whole hypotenuse of the big triangle over its adjacent leg is equal to the adjacent leg over this piece that was created. Y'all see it? So this is also true. What is C over A going to be equal to? If C over B equals B over X, then what is C over A going to equal to? A over Y, very good. See it? So big hypotenuse over adjacent side equals adjacent side over segment of hypotenuse. Hypotenuse over adjacent side equals adjacent side over piece of the hypotenuse. So after this rule, now you're going to be given some triangles, and you're going to be asked to use that rule to find some lengths. So here's what we got. We got this right triangle. Here's our altitude drawn to the hypotenuse. This piece is a 20. Here's a Z, X, Y, and a 5. So what you have to do now is take the rule, okay? You have to take this rule, all of these rules, and you have to apply them to this picture, which is another right triangle that just got rotated, all right, maybe 90 degrees clockwise. And you have to use these proportions to solve for these missing variables. So the first thing you want to do here is you want to take this hypotenuse, and what's that hypotenuse going to be equal to? 25, good. And now let's look at the easiest rule that came from this last theorem. It said that this altitude was equal to the geometric mean of the two pieces it created, right? So can we apply that here to solve for x? Wouldn't x, let me kind of break these apart a little bit. What's x going to be equal to? The square root of 20 times 5? So x equals the square root of what? 100. And what does that equal? That's 10. So your x is equal to 10. Now we're going to use these second rules, proportions, to solve for y and z. So look what we said up here. We said that this whole hypotenuse, which was C, over its adjacent side, B, equals its adjacent side over that over its adjacent segment. So how do we apply this up here to solve for y? Can we do 25 over y? 25 over y is going to be equal to, what's it going to be equal to? Look at the picture. We had hypotenuse over adjacent side equal to adjacent side over segment. Very good, y over 5. So if 25 over y equals y over 5, we can crisscross multiply, so y squared equals 125. If we square root each side, then y equals the square root of 125. And 125 has perfect square as a factor. So if y equals the square root of 125, then y equals the square root of 25 times 5 times the square root of 5. So y equals 5 radical 5. So there's your y value. And now we can use that same proportion to solve for z. Entire hypotenuse over adjacent side. So 25 over z equals what? 25 over z equals z over 20. Good job. All right, so again, now it's just crisscross multiply and solve. So we got z times z is z squared equals 25 times 20. Guessing 500. 500. Z squared equals 500. If we radical each side of this equation, then our z is going to be equal to the square root of 500. That's going to be the square root of 100 times the square root of 5. And z is going to be equal to 10 times the square root of 5. A lot of information packed into a small section of the textbook, but very, very, very important stuff. All right, so does anybody have any questions about finding the geometric mean of two numbers, finding the length of an altitude, or finding the length of a leg of a right triangle? Yes, sir. Yeah, what they'll do is they'll say solve for y or solve for the variables, list your answer in simplest radical form. If it says simplest radical form, then your answer is going to have a radical in it if it's not a perfect square. Or they will say list your answer as a decimal rounded to the nearest tenth. If they say that, then you can go back to these earlier steps, and when you get to the square root of 125, you can find that square root in your calculator and just list your answer as a decimal. So it's all going to be based on how the question's asked. And then sometimes they'll say list your answer in simplest radical form and as a decimal rounded to the nearest tenth, and that's when you have to do both. All right? Any other questions? All right, so here's your assignment for today. In the workbook, page 97. You got 1 through 14. And then on page 98, you got 1 through 10. When you complete that assignment and you've got your notes in front of you, make sure that you're going to check focus. For homework. If you people at home don't have any questions, I'm going to end this Zoom meeting.